Okay, so today we're going to be talking about integration. And integration is the reverse of finding a derivative. And sometimes what happens is they give you an equation, they give you a derivative. And basically, your job is to return it back to the function or equation it was. Uh, this is called an antiderivative. And don't worry too much about it, but I mean, as far as the name goes. But basically, keep in mind, we're returning it to its original function. And the key here to remember is that we can return it to just about completely what it was, but we can't return the constant at the end. There could be a constant at the end, and we can't figure that out by just turning it back with undoing the derivative. So let's try this anyway. My first step is going to be to, let's rewrite this. It says dy over dx, that's how I know this is a derivative. And I'm going to go ahead and I'm going to rewrite this now. It's the same thing. It's still a derivative, but it's going to be 3x to the negative 4, and then plus 32x to the third. Now, keep in mind, if you want to think of it in simple terms, when we're doing derivatives and integration, derivatives, you multiply and by the exponent and then subtract from the exponent. Integration, we add to the exponent and then we divide by the exponent. I mean, very simply put, that's what's going on. So in this case, when we're doing integration, I'm always going to write the base first. And then I'm going to add to the exponent, so that's going to become a negative 3. And then I'm going to multiply, or I'm going to divide by negative 3. 3 divided by negative 3 is negative 1. And we don't got to write it, but I'm going to write it. And now I go on to the next one, which again, I'm going to write the base here. I'm going to add 1 to the variable, and then I'm going to take this number and divide by it. So 32 divided by 4 is going to be 8. Now, this is almost the original equation. There could be a number at the end. There may not be, but there could be. Number, a constant. And so the way I've got to figure this out is some way they're either going to either hand me, in this case they hand it to me, they're either going to hand me an x or a y, or I'm going to have to figure it out. And so the way I'm going to do this now is I'm going to substitute in the point that I know is on the original equation. And then that gives me 4 is equal to negative 1 to the 1/2 to the negative third plus 8 times 1/2 to the fourth plus c. And you'll notice we've got an equation here where the only thing I don't know is c. And go ahead and pause this and try to figure out what c is going to be, and then start back up again when you're ready. Okay, so hopefully you did that and you found out that c was 11.5. When I do all this multiplication and power stuff, I get negative 7.5, and all I got to do is get the c by itself by adding 7.5 to both sides. And now that I know what c is, I go and rewrite my equation, which is going to be 3x to the negative, whoops, wrong equation. Let's try this again. 1, 2, 3, 4, 5, 6. Okay, it's going to be negative 1x to the negative third plus 8x to the fourth, and then it's going to be plus 11.5. And it's not really required, but if you want to, you could fix the negative exponent. This is going to become negative 1 over x to the third plus 8x to the fourth plus 11.5. If you do that, then the grader is going to really know that you know what you're doing. All right, so hopefully that made sense. Let's take a look at what the rubric looks like. All right, so you'll notice here's what they're looking for. they're looking for this, okay? Now, this is going to get you these two things, 1 point, 1 point, okay? In these brackets here, I think that they're saying here is that you might see that. You may have written that, but it's not going to cost you a point at this spot. Now, the method point is substituting in the point, the y, and then putting a plus c here. All right, and see now the final answer is what they're looking for to get my 4 points. So integrating, you can get 2 points for the integration, then 1 point for as far as a method goes, is substituting the point back in, and then getting the correct answer. That's your 4th point. All right, so this is again a pretty common thing to have to do. It doesn't happen on every single test, but it does happen. And it's not a particularly hard thing, but keep in mind that, one of the things we use integration for is to take a derivative and put it back to where it used to be before we found the derivative. All right, so let's take a look here. We have number 2. In number 2, it says I've got this equation, and it says to find the exact area of the region bounded by the curve and the x-axis, and the lines x equals 0 and x equals 4. Now, finding an area under a curve is also a pretty common thing. It could be bounded by the x-axis or the y-axis, and you have to pay close attention. Sometimes there'll be a picture, and in this case, there is no picture, but you don't require a picture. So we're going to use integration to do this. And basically, our first step is going to be to take this original function and rewrite it with powers. So let's start this. We've got 2 times 3x plus 4 to the 1/2 power, and then minus x. Now basically, again, if you're going to really kind of explain what's going on here, I'm going to integrate y in terms of x, and I'm going to use these 2 boundaries that they've set for us. So basically, if I was wanting to state what I'm going to do here, is I would go from 4 to 0, and I'm going to integrate this in terms of x, okay? Now, basically, this is going to be, oops, I forgot the minus x. Oops, don't forget that. Okay, so to do this, remember, I'm going to add to the exponent and then divide. So I'm going to start by writing my base here. 3x plus 4. Now, I'm going to take this and I'm going to raise it to the 3/2 power, because that's 1/2 plus 1. This has already got a 2, and what I'm going to do is I'm going to make it 2 over 1, and you're going to see why in a second. Because what's going to happen is I could divide by 3/2, or I could multiply by the reciprocal. In this case, I find it more convenient to multiply by the reciprocal. So this is going to be multiplied times 2 over 3. And then the other thing is, keep in mind, I'm also going to divide by the derivative of the inside, which, again, dividing by 3 is the same thing as multiplying by 1/3. This is a very common thing for people to forget to do, the derivative of the inside. And see, now I'm going to look here at this last guy. And again, I'm going to write the base. Right now, it's a power of 1. So I'm going to make it a power of 2. And then what I'm going to do is I'm going to divide by 2, which is going to be the same thing as multiplying by 1/2. So this is a -1, you'll notice. So it's going to be -1/2 x squared. All right, now, I am going to clean this up a little bit. You'll notice I get 2 times 2 is 4, and then 9ths. So that gives me 4/9. And I'm not going to worry about going much further than that, because my calculator can handle all of this. Now what I'm going to do, though, is I'm going to put these brackets around here, and basically think of this as like function. This is a function, kind of function notation. And now what I'm going to do is I'm going to substitute 2 numbers into this, and I'm going to subtract them in order to find the area. And so what I'm going to do is I'm going to put a 4 in there and a 0 in there, and then I'm going to subtract them. So what I want you to do is I want you to pause this. I want you to substitute a 4 into all those, remember this is a 9. I want to put a 4 in all those x's, and then I'll write that number here, and then we're going to subtract if you put a 0 and get an answer. So pause this and then start back up again when you're ready. Okay, so hopefully you did that. It's not crazy important that you show that you've substituted everything in here. However, it really is important that you break this apart and show what I got when I put a 4 in, and then what I got when I put a 0 in, and then show that you subtracted them, and then you get the answer. Now, the reason that this is important to show is that most calculators that are in use for these Cambridge courses have the capability of actually taking a basic function like this and integrating it with boundaries. And so the way you show that you've done it by hand is to go ahead and put these two things. If you write this and go immediately to the answer, then you're running the risk of losing a point because of a method. Sometimes I see in the rubrics where they say that they've got to see something, and I can't remember if this is one of those or not. Anyway, that gives us our answer. It's going to be 152 over 9. Let's take a look and see what that says. So again, this is not required, but this is what's happening. And again, we wrote this. Now, this is what they want to see. And again, you'll notice how you're going to get a point for each term. So you're going to get 1 point for this and 1 point for that. It's not uncommon for people to forget. They spend all their energy finding the integration of this first thing and then forget to integrate this minus x. I don't know if it's because it's just a minus x and they feel like it's almost nothing, but it's easy to do and people do miss it, okay? So that's 2 points right there, getting both of those terms. Now, substituting the limits for 0 and 4 into the expression, that's a method point. Notice how we're showing this method, all right? And then they get a final answer. So I don't know necessarily that they need to see this, but they definitely need to see the subtraction going on. And then, of course, then we got our answer. And again, they put it like this, but you could put it like that, which is what we did, right? Right. And then that's it. So 4 points. Pay attention at the beginning because you can certainly, if you were to forget this second term, well, now that's cost you a point. You could still get this method point by substituting it into your expression here, into your integrated thing. However, there clearly is no way that you're going to get this 4th point. It won't be correct. So by making this one little mistake, forgetting this one little term, you now can only get 2 points out of the 4. And so it's just really important to pay attention to that first step. All right, so let's take a look at this one. Here, the diagram shows the part of a curve with the equation y squared equals x minus 2, and the lines x equals 5 and y equals 1. The shaded region enclosed by the curve and the lines rotated around the x-axis. Now you've got to really be careful again because now this is a rotation around the x-axis. This is the other big thing that gets done, and it's a kind of cumulative problem. It's definitely one of the tougher things that you have to do. And so there's 2 basic things to keep in mind. This is going to be spinning around, Let me see if I can make a sketch here. It's going to be spinning around, right? This x-axis, okay? Now, this is going to be spinning around. And then what's going to happen is I'm going to get this shape. However, it's only going to be this top part. It's going to be cut off. It's going to be this triangle, and then there's going to be this hollow part in the middle. Terrible picture, but here's what we have to do. To do this, what we're going to have to do is find the volume of wrapping around this shaded area, around the x-axis. And the way we do that is we integrate, we're going to multiply by pi, we integrate, and then instead of integrating y, we integrate y squared in terms of x, okay? Now, you might be thinking, why'd they make this y squared? Quite honestly, because they're trying to help you out. I want to integrate y squared. Well, they're telling you y squared is equal to x minus 2. They're basically trying to help you out. And then what I've got to do, though, is I'm going to find the integration of that, and then I've got to subtract the integration of rotating this around. Now, there's two ways to think about this. If I look at this right here, and again, imagine that it gets rotated around. Do you see how it's going to be a cylinder? Okay? So what's going to happen is that this shaded part is going to be on the outside. It is going to have volume or, texture or whatever you want to call it. It's going to have something. But this middle part, this middle cylinder is going to be a hole. Okay? And so there's two approaches to this. We could subtract the volume. So here, let's do this. We could go like this. So we can do the integration of x minus 2. Okay? And then we could subtract the integration. And again, now keep it. This is x, this is y equals 1. So y equals 1. All right? Well, what's 1 squared? It's still going to be 1. And so what we can do then is subtract and do the integration of that. Now, what are our boundaries? Good to see here. Clearly, one of our boundaries is going to be 5. Let's see, I mean, the upper boundary. And then the other boundary is going to be whatever this point is where they intersect. So that's going to be one of the first things we're going to have to do. See if you can figure out what this point is. It's where this curve and y equal 1 intersect. Pause it and start back up again and tell me what you find out. Okay, so let's take this equation. Y squared equals x minus 2. And then we're going to find out where it intersects with y equals 1. So if I replace this y with a 1, it's going to be 1 squared is equal to x minus 2. 1 is equal to x minus 2. X is going to equal 3. This point is going to be 3. Okay, 3 something. Actually, it's going to be 3, 1, right? So, now I know what my boundaries are. I'm going to go from 5 to 1, or I'm sorry, 5 to 3. And see, now all I got to do is these two integrations. And they're not particularly tough ones. So let's take a look at this one. If I integrate this, I'm going to start by writing my base. That's going to be x. I'm going to raise it from a power of 1 to a power of 2. And then I'm going to divide by 2, which is the same thing as multiplying by 1/2. Okay? And then what I'm going to do is I'm going to go to the next term, and this is minus 2. And keep in mind, whenever you're integrating a constant, it just add an x to it. So this is going to be minus 2x. Okay? Now, this is going to be the first part of our function. And what you want to do is always put a pi sign on here, because what happens is that our answer is always going to be some number pi. It's part of our formula, and we don't got to worry about it when we're integrating, so it's really easy to forget about. So write it down so you don't forget about it. And again, what I'm going to do is I'm going to go from 5 to 3. And see, then what I'm going to do is I'm going to take away the integration of 1, which if I integrate 1, it's a constant, it's going to be x. And it's also going to be from 5 to 3. All right, now again, I'm going to take that and multiply it by pi also. All right, so do this for me. First, pause this, and then substitute in a 5, and then the 3, and you're going to get two numbers subtracted, and then that's going to give you an answer, pi. And then we're going to take this number, and we're going to get two numbers, we're going to subtract them, and then we're going to get a number, pi. And we're going to subtract those two, and that's going to be our answer. So pause this, and then start back up again when you've got that, and we'll see what we got. Okay, so hopefully you did that. When I did this, I got, after I put a 5 in here, 5 squared, 25 times 2, 1/2, blah, 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 blah. I ended up getting 2.5. And then when I put in the 3, I got negative 1.5. And so if I do 2.5 minus a negative 1.5, that's going to give me 4 pi. And then for my second one, well, this is pretty easy because I put a 5 in there. Then it's going to be a 5. Come on. And if I put a 3 in there, it's going to be a 3. And 5 minus 3 is going to be 2. And again, we're going to do times pi. And so now I'm going to take this first one and subtract the second one. And that gives me an answer of 2 pi. Now the other thing is that keep in mind, you could have skipped this last part, though it wasn't very difficult. But this part here, because this is going to be a cylinder, and we know the volume of a cylinder. The volume of a cylinder is going to be pi r squared times the height, okay? Now, the height of our cylinder, laying down here, is clearly going to be 2. Our radius is going to be 1, because remember, this is going around the x-axis, so it's going to be 1 down to negative 1. So our radius is going to be 1. And then there's pi, okay? And see, the volume of that is going to be 1 times 2. It's going to be 2 pi, which is the same thing as if we do the integration. So if you wanted to, what you could do is you could rotate this top curve and then subtract the volume of this cylinder that's made, and then that would still give you the correct answer. All right, either way works. And then let's take a look here and see what they say. So first you can see they did that. The first thing they did was they figured out that that point is 3, 1. All right, that's going to give you a point. And don't get me wrong, just because they have it first, it doesn't mean necessarily that you have to do it first. But somewhere on your paper, they need to see that. And you'll notice they even write that. They need to see where it says x equals 3. And if you would have, even if you would have taken it and put it on the picture, I think if you would have said that, but if you would have done this, I think that maybe they would have accepted that. But they're looking for x equals 3, all right? And then here you'll notice again, they're not that worried about the pi sign at this point, but definitely we're going to do the integration here of this. And they want to show that you're going to integrate this x minus 2. And again, they're not that big, they're not worried about the pi sign at this point, okay? or they're even willing to accept it if you put 2 pi instead of 1 pi, all right? And then to do the correct integral, and again, they're okay with you not showing a pi sign. So here we've got our integral. Could be either one of these things. I could distribute it or not. And then taking the one and subtracting the other. All right, and you're allowed to, so if you got the incorrect value for 3 at the very top, as long as you used it and did this method here, you could still get this method point. And then here you can see this volume cylinder. And again, you can either you can do it by integrating, or you can find the volume of the cylinder. Either way, they need to see this 2 pi. That's the volume of the cylinder. And then you showing you subtracted those two. That's going to give them the answer. And then they would, technically, there's no reason not to do this. It should be 2 pi, but they would have accepted 6.28 because 2 pi rounded to 3 significant figures is 6.28. Okay? But this is no reason to do that. Just write 2 pi. Okay? So keep in mind, whenever you're looking at a problem like this, where it's up and it's not actually touching the x-axis or the y-axis, then what you're going to do is either find the area or the volume of the top one, and then you're going to subtract the area or the volume of the bottom one. And that's how that works. Anyway, this is a pretty tough problem, worth 6 points. Like the integration, you'll notice because you're doing a lot of stuff here, the integration isn't all that tough. And like I said, they've set you up. They're wanting you to use x minus 2. So anyway, it's not terrible. Take a look here. Number 4. In number 4, we've got a situation where they're giving us a curve, and they're telling us there's an equation that exists, f of x, such that its derivative, and remember that's derivative notation, is equal to this. So now, okay, so this one you should be able to do. I'm going to pause this. This is simply a situation like where they're giving you a derivative. They're just using a different notation, and you got to be very comfortable with this. This is the same thing as dy over dx as far as indicating you're looking at a derivative. We'll use this notation whenever they described it as being f of x, okay? So if it's y equals, they'll use dy over dx, and if it's f of x, they'll use this. But this is basically them telling you that this is a derivative, and they want you to work it backwards and find the antiderivative and use the point to find c. So what you do is pause this, go through and do the whole thing, and then start back up again when you're ready. Okay, so hopefully you did that. My first step is going to be to rewrite their original derivative by creating the powers here, moving this x squared up into the numerator and then making the power negative. And so the next thing is to go ahead and start doing my integration. When I do that, I'm going to start with y equals, whoops, technically it should be f of x equals. I'm just used to writing y equals. But technically, you'll notice they said it was f of x. Right? And then we're going to go like this here, and I'm going to, again, integrate. So I'm going to write the base. I'm going to raise the power. And then what I'm going to do is I'm going to divide by the power. So 6 divided by 3 is going to be 2. And then what I'm going to do is I'm going to do the same thing here. Write the base, raise the power to -1. Take -8, divide by -1, get +8, and then put a plus c on the end. And see, now all I've got to do is substitute in my values. 7 is equal to 2 times 2 to the third plus 8 times 2 to the -1 plus c. And if you've written it like this, then you probably could use the equation solver in your calculator to figure this out. At the very least, you could use the stow function and stow the value of 2 into x, and then write 2x to the third plus 8x to the negative 1, and get this number here. But what I'm going to say is I'm going to find out that all this is going to equal 20. And when I subtract the 20 on both sides, c is going to equal to negative 13. So then keep in mind, the answer is not c equals negative 13. The answer is going to be f of x is equal to 2x to the third plus 8x to the negative 1, and then minus 13. And again, if you want to show off a little bit, go ahead and fix it. It shouldn't be a requirement. Okay, so that's how we go with that. Again, let's take a look at the rubric and see what that says. You notice here what they're looking for are these two things, right? And again, what they did was they got rid of the negative exponent, but you'll notice that it doesn't make a difference what form it's in. That's going to give you 1 point, okay? And then what they're going to do is you have to figure out c, and again, they need to see this methodology you're using. They're going to see every iteration, but they have to see that you've substituted in 2, and then you've got this, and then they're expecting to see that c is equal to negative 13, and then this should be the answer. Now, notice again, technically, based on their question, it should say f of x. They will allow y equals. And, you know, if you wrote y somewhere in the problem, it's not going to be in the world. That, you know, one of the nice things about this is they don't seem to be overly concerned about that kind of notation, but technically, you know, they told us the function was f of x, so we should name it f of x. But that's how that goes, right? So again, that's 3 points. That's not, you know, this is a pretty basic thing. It's not worth a ton of points, but really it shouldn't be all that hard. And if you take a look at the integration, as far as integrating this, that wasn't the toughest kind of integration to have to do. That's not why it's not worth that much. You know, you don't have to do the reverse chain rule. Probably would have been worth another point if you had a reverse chain rule in there also. All right, so anyway, that's good there. All right, so let's take a look at this one. Reading this, it says the diagram shows part of the curve with the equation y equals x to the 1/2 plus k x squared plus x to the negative 1/2 is equal to k. It's a positive k constant. All right, now the diagram shows part of the curve. Find the coordinates of the minimum point. All right, so now again, if you see this picture, you might be thinking immediately that we're trying to find the area of the curve. And quite honestly, you're probably going to end up doing that somewhere, or at least the volume. You're going to do something, but that's not what they're asking you. So make sure you're reading and really paying attention to what they're asking you for. Find the coordinates of the minimum point, okay? The minimum point of a curve is a stationary point, okay? So basically, they're asking you for the stationary point. And see, what makes this a little bit confusing is this picture looks like we're finding the area of the curve, but this first question really has nothing to do with that. If you recall, what we're doing is we're finding stationary points. That's about derivatives, because at a stationary point, the slope is going to equal 0. So what we need to do is go ahead and start. Let's try up here. All right, and we're going to find the derivative of this function right here. And then you notice how everything is in terms of k. So what happens is we're not going to know what k is. There's going to be k's floating around in here. We just got to treat them like a number. So remember, it's not a variable, it's a constant, it's a number. So anyway, if I do this, this is going to be 1/2. Here, I'm going to write it up here. Y equals x to the 1/2 plus k squared x to the negative 1/2, right? Okay, so if I'm going to find the derivative, I'm going to label it like this to let people know that's what I'm doing. And then what I'm going to do is I'm going to multiply by the exponent. So that's going to give me 1/2. Then I'm going to write this, and then I'm going to subtract 1 from the exponent. That's going to give me negative 1/2. And then I'm going to move on. And again, this is a number, not a variable. So I'm going to take this negative 1/2 and I'm going to multiply it. So that's going to become negative 1/2 times k squared. and then it's going to be x, and I'm going to subtract 1, so this is going to be the negative 3/2. All right, now that's me finding the integration of, or finding the derivative of this. Now keep in mind, the stationary point is where this is going to equal 0. So I'm going to set this equal to 0. And in this case, I'm going to try to leave this way for a second. Okay, now, if it's me, keep in mind what we're trying to do is that we're trying to find the value of x. So we're going to have to try to get x alone, all right? Now, the problem they have here is that they've got a couple of them. And I don't know about you, but you see how this is minus and there's a 0 over here? I'm probably going to go ahead and add this to both sides. So when I add this to both sides, it looks like this. 1/2 k squared x to the negative 3/2 is now equal to 1/2 x to the negative 1/2. Okay? Now, keep in mind, I'm trying to get the x by itself. So what I'm thinking about doing now is getting this out of here. So I'm going to divide by 1/2, which if I do that over here, that kind of makes me feel good because those are going to go, right? And I'm going to divide this by x to the negative 3/2 and divide that by x to the negative 3/2. Okay? So now what's going to happen is I'm going to end up, when I do this is going to cancel out, this is going to cancel out. It's going to leave me with k squared. Okay? Now, these two 1/2 will cancel out. And keep in mind, whenever I'm dividing monomials, I subtract the exponents. So essentially what we're doing is negative 1/2 minus negative 3/2, which is negative 1/2 plus 3/2, minus the negative, right? And so then what do you end up with when you add those? You should end up with a 1, right? So now this is x to the first power. And I got x by itself. What does x equal? X equals k squared. Okay, now keep in mind, that's the x part of the vertex, the stationary point. Okay? That's the x for the stationary point. We took the derivative, we made it equal to 0, and we solved for x. X equals k squared. So now, if this had been a number, and I found out that x is equal to 3, then how would I find out what the y value is? Well, I'd go back to the original function, and I would substitute in what x was equal. I'm going to still have to do that because I have to find out the coordinates, and I need the y value. So now what's going to happen is I'm going to write y equals, but instead of x, I'm going to do k squared, and it's to the 1/2 power. And then I'm going to plus k squared, because that already is there. I'm just writing it down. But then I'm going to multiply it by k squared to the negative 1/2 power. So this kind of tests your skills with exponents and raising the powers, okay? If I'm raising a power to a power, I multiply the powers. So this is going to end up being k, because it's 2 times 1/2, so it'll end up being k to the first, okay? I'm going to raise this to the power, so this is going to be k to the negative 1, because 2 times negative 1/2 is going to be negative 1, and I'm just going to go ahead and write this. So I haven't done anything with this yet, but when I raise this to this power, it's going to be k to the 1, okay? Or I'm sorry, negative 1, because it's negative 1/2 times 2, right? And see now when I multiply these two k's together, the base will stay the same, and it's going to end up being, when I multiply these two together, I'm going to add their exponents. So this is going to end up being another k to the first. So the y value is 2k. So if you will, the coordinates of that point are going to be k squared, comma, 2k. Now let's go back and revisit the question. They said find the coordinates of the minimum point of the curve, giving your answer in terms of k. Well, I totally did that. I've got k's in my answer. That's what they are, right? So that's part A of this. There's going to be multiple things we got to do. All right? But a lot of this work is about these exponents and how your ability to handle them. We could have gone through and made them, made them square roots and square roots cubed, and I'm not sure if that's going to be easier or harder. This happens to be just the way I did it. There's more than one way. All right, so let's take a look at the rubric. You'll notice how they had the derivative here, right? So that's going to give you 2 points. We're basically looking for these two parts. They're looking for those two parts to be accurate. That's going to give you 2 points. Making it equal to 0, that's going to give you a point. Okay, taking your derivative and making it equal to 0. And then one correct algebraic step. So after you make it equal to 0, if you can make one correct algebraic step, then you can get this method point. So again, you'll notice how me taking this negative 1/2 k squared x to the negative 3/2 and adding it to the other side, that's a correct algebraic step. I don't know if it's faster or slower, but if I make this one step, the rest of it could be a train wreck. But as long as I make this one algebraic move that does make sense, they'll give me this method point. All right, I can't just write all this stuff equals 0 and then not do anything to solve it. That won't get you anything. You have to. The method is to make it equal to 0 and then to try to solve it. Okay. Now, again, also to find this, your derivative has got to only have the 2 terms, so you can't have screwed it up totally. All right. And so then, lastly, they're just looking for this. Okay. So you'll notice how all this work, all this stuff, they're not really caring so much about how you get there. Just get there. Anyway, that's the way you get those 4 points, right? 2 points for doing the derivative correctly, 1 point for using the method and making it equal to 0, and another point for getting the right answer. So you could get 3 out of these 4 points if you could just find a derivative, and if you can just not let this k drive you crazy, which, again, sometimes that really bothers people. All right, so let's take a look at part B now. Same question, only now this is part B. In part B, it says, the tangent at the point on the curve where x equals 4k squared intersects the y-axis at P. Again, so here we go. There's nothing to do with the picture, okay? The tangent of the curve. When they're talking about tangents to curves, there's 2 possibilities. Either we're talking about a quadratic, and we're going to have to use the discriminant, or in this case where it's not a quadratic, then we're talking about using a derivative, and a tangent we're going to use this derivative to find the slope of the tangent line, right? So the tangent at the point on the curve where x equals 4k squared, all right, so 4k squared intersects the y-axis at P. And so they want us to find the point P, this y coordinate, okay? Basically, if you will, that's the y-intercept of the tangent line. They want to know the y-intercept of the tangent line. All right, so let's go ahead in B here. First, we've got our derivative, which we've already found, but I'm going to rewrite, is equal to 1/2 x to the negative 1/2 minus 1/2 k squared x to the negative 3/2. We'd already figured out the derivative so that we won't have to redo that, okay? And now what we're going to do is we're going to substitute in this x and find the slope. So again, we're using the derivative to find the slope. But you'll notice we're still in terms of k. We're dragging this k around, and we can't let it bother us. So here we go. This, I am thinking that it might make sense in this case to rewrite this without the negative powers. So if I do this right now, technically that x is on the top, all right? So this is going to be 1 over square root of, or 2, the 2 stay down here, but the x is going to move down, and it becomes the square root of x, okay? And then this, again, it's minus, the 1 will stay on the top, the k squared will stay on the top, the 2 will be on the bottom, and then the x, this is going to be that x to the third square rooted. So it looks like this, okay? So now what I'm going to do here is substitute in this x they want us to substitute in, which is 4k squared. So now it's going to be 1 over 2 square root of 4k squared minus k squared over 2. And again, I'm only replacing the x's with what they told me x was. Again, 4k squared, but it's to the third power, right? And again, we're still square rooting, okay? All right, so now what we can do is find the square roots. So what is the square root of this? What's the square root of 4k squared? Well, it's going to be 2k. And then 2k times 2 is going to be 1 over 4k. All right, that's not terrible. And see, now here what we're going to do is we're going to have to, well, let's write this so we don't forget it. All right, now the 2 is going to be out here. And then we're square rooting, okay? Now, 4 to the third power, that's going to be 64. X squared to the third power is going to be x to the 6th, okay? And see, now, let's go ahead and do this a little further. The k squared will still be on top. This is still going to be 2. The square root of 64 is going to be 8. The square root of x to the 6th is going to be x to the 3rd. Think of it, the square rooting is raising it to the 1/2 power. So I'd multiply 6 times 1/2. Anyway, that gives me this, okay? 2 times 8x to the 3rd. So now I've got 1 minus 4k minus k squared all over 16k, no, 16k, what happened here? Oops, look and see where I screwed up. So what happened was I replaced this with a 4k squared, but I replaced this with a 4x squared. Oh my, I did it all the way through here. I'm like, where are my k's? And so let's fix this. Sorry about this. So here, this is actually supposed to be k. This is actually supposed to be k. This is actually supposed to be k. And so now when I go ahead and multiply this, it's going to be 16 k to the 3rd, right? All right, now I can't do much with this first fraction, but I can do this. Remember, I've got k to the 2nd over k to the 3rd. So what that is going to be is that's going to be 1 over, and remember, when I divide two variables, I subtract their exponents, so it'll be k to the negative 1 power. So this is going to be, 1 over 16k. All right, now this is a lot simpler. I've got two fractions. I could get this to be a common denominator and multiplying this times 4 and this times 4. And so now what I end up with is going to be 4 over 16k minus 1 over 16k. And that's going to give me 3 over 16k. And that is the slope. And you're like, oh my God, you got to be kidding me. Yes, that's the slope. So again, let's revisit. They told us to find the tangent line at this point. Typically it would be a number, but they gave us this instead. We took the x value and substituted it into the derivative. And after a lot of work, we found the slope. Now this is our slope of our tangent line. So now what we've got to do then is we've got to figure out what the, we've got to figure out what the equation is going to be, right? And we're going to do it the same way we would always do it. Y equals mx plus b. Y, do I know what y is? K squared y is equal to, no, I don't know what y is equal to. So what I'm going to do is take this x value they gave me, and I'm going to plug it into here. So when I do that, it looks like this. Y equals 4k squared all to the 1/2 power plus k squared times 4k squared to the negative 1/2 power. And when I take 4 to the 1/2 power, that's going to be 2. And when I take k squared to the 1/2 power, that's going to be k. And then this k squared is going to stay the same for right now. If I do 4 to the negative 1/2 power, take a second and try that in your calculator. 4 to the negative 1/2 power is going to be, man, I don't remember, 1/2. So this is going to be 1/2. 4 to the negative 1/2 power is going to be 1/2. And then k squared, well, I'm going to multiply these together. And so I'm going to get k to the negative 1. And then when I go ahead and multiply these together, I'm going to get 2k plus k squared times this is going to be 1/2. And k squared times k to the negative 1 is going to be k. And so what happens is I find out that y equals 2.5k. So now I know the y value, I know the slope, I know the x value. So what I'm going to do then is put this in. 2.5k is equal to 3 over 16k times the k, which is going to be 4k squared, if you want, over 1 plus b. And so I'm probably going to multiply these together, and I'm going to get 12k squared over 16k. And then this is still going to be 2.5k equals and plus b. And if I take this and divide it, 12 divided by 16 is going to be 3/4, and k squared divided by k is going to be k. So that's going to be 3/4 k is equal to, and I guess I'm going to go like this, 5/2 k plus b. So basically b is going to be 5/2 k minus 3/4 k. And if you do that, well, we could just make this 10, right? Make it fourths. So it'll be 10 fourths, okay? And so when I subtract it, it's going to be 7 fourths. So B is going to equal 7k over 4, which is the y value of the point where the tangent line intersects the y-axis. Now, I got to tell you, that's rough. That's a rough one. We're still in terms of k. But anyway, there's that. Let's take a look at the rubric. Again, you know, we put this in here. And what are they doing? Oh, right. They're got the derivative. They're substituting in. And they got three over 16k. That's a lot of work there. Maybe try it a different way. Maybe I didn't do it the fastest way. All right, that's going to get you a point. This other 5k over 2. Let's see. That's 2.5k. So that's us finding out the y value when we know the x value is 4k squared. That gets you a point. And then find the tangent line using the method. So, you know, they got, this is actually point slope form, or you could do y equals mx plus b, and you can see where we got the y, we got the slope, we got the x plus c. Using this method to find the equation, and then finding out that c is equal to 7k over 4. That's the answer. I got to tell you what, that's a lot of work for 4 points. If it were me and I was taking this test, I might save this problem for later, but it all depends on how you feel about it. You have to be careful that you don't get into the middle of a test and go down a rabbit hole and you're spending all kinds of time on something that maybe you're not doing right, and you're not looking at problems that you could have done well and done correctly. So you have to be smart about what you do and what don't do. Anyway, like I said, this is actually a derivative question and not an integration question. And then C, now we're getting to integration where they want us to actually find the area under the curve, okay? And if I have this y, okay, what we're going to do is we take this, and again, we're still dealing with k's, it looks like. Find the area of the k in terms of k. Okay, so here we've got our equation, and what we're going to do is we're going to integrate it. So again, if I'm doing that, I'm going to start by writing the variable, and then I'm going to raise the power by 1, and then divide by it, or in this case, multiply by it, the reciprocal. What I want you to do is pause this and see if you can integrate this, and then start back up again when you're ready. Okay, so hopefully you did that, and if I start with this, I'm going to get add 1, so it's going to be 3 halves. And then again, I could divide by 3 halves, or I'm going to multiply by the reciprocal. And in this case, I find it easier to multiply by the reciprocal. And then I come over here. Now remember, this is a number, not a variable. So I'm going to take this and I'm going to just rewrite it. And then, because I know there's no way I'm going to be able to divide by it. And then I raise this power, so it's now a -1, and it's going to become a positive 1/2. And then what I'm going to do is either divide by 1/2, which is the same thing as multiplying by 2. And that gives me this. Okay, now I'm going to integrate from 4k squared to 9/4 k squared. These are my x values. Okay? So basically what I'm going to do is substitute in 4k squared into both of these variables and get a number. And then I'm going to substitute 4/9 k squared into both of these, and I'm going to get a number. And I'm going to subtract those. Pause this and see if you can't pull that off, and start back up again, and we'll see where we're at. Okay, so hopefully you were able to do that. Let's see what we got here. If I put a 4k squared in here, it looks like this. Whoops, 2/3. And then it's going to be 4k squared over 1. And this is going to be, whoops. Hang on, let's reverse this. All right, so 2/3. And then I'm going to put this in here. So it's going to be 4k squared to the 3/2. And then it's going to be plus 2k squared. And then I'm going to put this in here. So it's going to be 4k squared to the 1/2, right? And so when I go and multiply this, well, first I have to do the powers first. So 4 to the 3/2 is going to be 8. And then when I do k and I multiply these exponents, 3/2 times 2 is going to equal 3. So that's going to give me k to the 3rd. And I still have this 2/3 in front. All right, so I did this 4 to the 3/2 power, and I got 8. Then I took k squared, multiplied the exponents, and got k to the 3rd. That still has to get multiplied times 2/3. 8 times 2/3 is going to be 16/3, k to the 3rd. All right, now when I do this, I have to raise to the power first. Well, 4 to the 1/2 power is going to be 2. K squared to the 1/2 power is going to be k. So this ends up being 2k, and then I'm going to multiply it by 2k squared. So that's going to be 4k to the 3rd, and it's going to be plus. And so I end up with 16/3 k x to the 3rd, blah, 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 blah. When I add those together, I get 28/3 k to the 3rd. Now, all I've done is plugged in this 4k squared. Now, I'm going to put it up here so I don't forget. Now I'm going to plug in the 9/4 k squared. So that looks kind of the same way. I'm going to start here. It's going to be 2/3, only it's going to be 9/4 k squared to the 3/2 plus 2k squared, and it's going to be 9/4 k squared to the 1/2. All right, so again, if I do 9/4 to the 3/2 power, I'm going to get 27/8 k to the 3rd times 2/3. And that's going to give me, well, when I multiply these, I'm going to get 9/4 k to the 3rd. And then here, when I do the same thing, this is going to be 3/2 to the half. You know, when I raise to the half power, it's like square rooting. So this is going to be 3/2. This is going to be k. I still have to multiply it times 2k squared. So 3 times 2 times 3/2 is going to equal 3. And so this is going to end up being 3k to the 3rd. And again, we're adding those. So when I put those together, I'm going to get 21 fourths k to the third. 21 fourths k to the third. And see, now all I'm going to do is subtract those. I'm going to do 28 thirds minus 21 fourths. And then my answer for the area under the curve is going to be 49 twelfths k to the third. Okay, so that's finding the area in terms of k. Quite honestly, another really rough problem. All right? But anyway, maybe you can find an easier way to do it than what I did. And then you look at the rubric here. They're doing they integrate it. Here we got this, any kind of unsimplified form. Then what happens is we get these two guys here. We subtract them. Woo! And you'll notice they got the different parts. And then we end up with 49k to the third over 12. This is all broken down into parts so they can do the grading. But like I said, you need to do the derivative correctly. That gets you a point. You need to apply the limits, or I'm sorry, integrate it correctly. And then you integrate it correctly, that gets you a point. And then you've got to substitute in the x values and subtract them. That gives you a point. And then getting it right gives you a point. Okay, so here is number 6. Here we've got a problem where they have a curve and a straight line, and they want us to find, by calculation, the coordinates of A, B, and C. All right, well, A is the y-intercept of the line right here, okay? So A, if I just rewrite this 2y plus x equals 8 as, you know, in y equals mx plus b form, 2y is equal to negative x plus 8, y is equal to negative 1/2 x plus 4. B is going to be that point. This is going to be 0, 4. That's A. A is 0, 4. Okay? B. B is where this line and this curve meet. All right? So all we got to do is make them equal to each other. I've got this set up this way, so let's see here. If I write, let's go ahead and write this. Y equals 8 over x plus 2. And if I substitute in this other line, we're writing y equals negative 1/2 x plus 4. Those two are going to intersect at a particular point. In fact, this way might be easier if I rewrite it the way it was originally. If I substitute y into the other y, it's going to be 2 times this. And then plus x equal 8. So do me a favor and see if you can't solve for x. Pause this and see if you can't figure out what x is. All right, hopefully you did that. 2 times 8 is 16. This is going to give us 16 over x plus 2 plus x equals 8. I'm probably going to subtract the x on both sides and get 8 minus x. And then what I'm going to do is multiply both sides by x plus 2 and get these guys to cancel out. So that leaves me with 16 is equal to, let's see, this is going to be, well, this is going to be a little weird. Let's do it like this. So negative x squared, and then it's going to be, let's see, minus 2x and plus 8x. And then minus 16. And so when I clean this up, if I get everything on one side, I'm going to make this positive. So I'm going to move everything over here. So this is going to be x squared. When I add the 16, they're both going to cancel out. And when I add the 2x, well, let's put those together. So that's going to be 6x. And so when I subtract them, I get this. And see, now what I'm going to do is factor this. This is going to be x times x minus 6 equals 0. X equals 0, which we knew because it does intersect where x equals 0. That point's going to be 4. We wanted to know the other one. That's where x equals 6. This is going to be 6. That's going to be, and again, calculations. They want the point. So what I'm going to do back up here is go back to the original equation here. If I put a 6 in here, 2y plus 6 equals 8. 2y equals 2. And then we've got y equals 1. All right. That gives me the point B. Oh, yeah, B. B is equal to 6, 1. Okay? And then they want to find C. Now, what it says C is the point that lies on the curve where the tangent is parallel to AB. So C is got a tangent line that's parallel to this line right here. And so again, once we're talking about tangent lines, we're talking about derivatives, okay? I need to find out what this slope is. Well, I already did that. That's negative 1/2, right? So basically, this is another situation where they're giving me the slope, and then I have to find the x value. And the first step then is going to be to find the derivative of this. So let's go ahead and write the equation. Y equals 8 over x plus 2. And what I'm going to do is I'm going to rewrite it. So now keep in mind, all of this has to move to the top, to the negative 1 power. Okay? Now, what I want you to do is take a minute, pause this, and try to find the derivative of it. Use the chain rule, not the reverse chain rule, the chain rule. We're actually finding a derivative in this case. Pause it, start back up again when you're ready. Okay, awesome. Hopefully you did that. So if you multiplied by negative 1, you got negative 8. Rewrote this. And then you subtracted, so you got negative 2. You also multiplied by the derivative of the inside, which in this case happens to be 1. And so we end up with this as being our derivative. Okay? Now, they've told us that the x value we're looking for is where the slope is equal to the same as the parallel line. So I've got to make this equal to negative 1/2. In this case, I'm not finding a slope. They're giving me a slope. And see, I'm going to go up here now. Let's see, negative 1/2. And see if I rewrite this as negative 8 over x plus 2 squared, right? And so then if I cross multiply, I'm going to get Um, hmm. And actually, well, it doesn't make a difference. We'll go like this. I don't want to confuse anybody. We're going to multiply -1 times this, but not really, because I can't square it yet, or didn't square it. And that's going to equal -16. And before I square this, I'm going to divide by -1 and divide by -1. And that's going to give me plus and plus, right? And now when I square this, it's going to be x squared plus 4x plus 4 is equal to 16. And then when I subtract, I get x squared plus 4x. 4 minus 16 is going to be -12. And then when I factor that, x and x, two numbers are multiplied to get 12 and subtract to get 4, 6 and 2 plus 4 minus 2. That tells me that my x is either going to be -6, which is not possible since clearly this is positive. So then my answer has got to be a 2. Okay? And then I've got to find the y value. And so x equals 2. I'm going to plug it back into here. And so that's going to be 8 over 2 plus 2, which is 8 over 4. And then my y is going to equal 2. So C is 2, 2. Okay? I found A, B, and C. And so that's worth 6 points. That's a lot of work, but it's actually some decent points, and it's not crazy. And if you take a look at the rubric, all right, simultaneously, use the method of solving simultaneously. And then x equals 0, x equals 6. We know 0, 4. We know 6, 1. And here we've got c, so we got this and make the derivative equal to -1/2. Find out that this is going to be 2. All right, so again, basically it looks like you get 1 point for doing the differentiation, and then you get a method point for making it equal to -1 and then solving it, and then you get the actual A point for actually doing it correctly and getting the C 2, 2. All right, so that's the first part. And then part B, what they want us to do is they want to find the volume generated by this shaded thing rounded around the x-axis. All right, so this is similar to the one we did a few minutes ago. What we're going to do is we're going to rotate this around the x-axis, and then we're going to rotate this around the x-axis, and we're going to subtract them. The top one minus the bottom one. So keep in mind what we're going to do is going to be integration. If we're going to do this, we really need this to be y equals, and we already know that this is y equals -1/2 x plus 4. All right, that's the guy on top. That's what we're going to start with. And so again, we're doing volume. And remember, what's going to happen is when we're doing volume, what we do is we take y and then we square it, and then we're going to multiply it by pi, right? Now, in this case, y is not squared, so the first thing we're going to have to do is we're going to have to square this. So let's do this, -1/2 x plus 4 squared. So just like any kind of binomial, if I square this, what's -1/2 times -1/2? That's going to be +1/4, and then it'll be x squared, all right? Then I'm going to multiply these two together, so that's 4 times -1/2. That's going to be -2, but then I'm going to double it, so it'll be -4x. And then I'm going to square the last term, that's going to be 4 times 4, that's going to give me 16. And that gives me my y squared. That's y squared. And see, that's the thing I'm actually going to integrate, okay? And so let's go ahead and start with that. Now keep in mind, we're going to do two integrations. We're going to first integrate this one, and then we're going to integrate this one, and then we're going to subtract them. And remember, we found out this point is 0, 4. So that's one of our boundaries. X is equal to 0, since we're rotating around the x-axis. And this point was 6, 1. Well, just say 6. I don't know why I wrote that. This is going to be 6. All right, so our two boundaries are going to be 6 and 0, right? All right, so the thing is, I haven't integrated yet. So let's go ahead and do that. Start by writing, well, why don't you try it? Why don't you pause this and see if you can't integrate my y squared and see what you get. Pause it and start back up again when you're ready. All right, awesome. Hopefully you did that. If you did, you hopefully started with the x and you raised the power to 3. And then instead of dividing by 3, I'm probably going to multiply by 1/3. 1/3 times 1/4 is going to be 1/12. Then I'm going to look at this x. I'm going to write it down. I'm going to raise its power to 2. In this case, I'm happy with dividing. -4 divided by 2 is -2. And then the 16, keep in mind, when you integrate, you just, constant, you just put an x on it. And see now, that's my integration function. I'm going to do 6 and 0. So pause this, and why don't you find out what happens when I put a 6 in there, what happens when I put a 0 in there. And keep in mind, this is volume, so I'm going to multiply it times pi after we're done. Pause it and start back up again when you're ready. Okay, so hopefully you did that. And in this case, when I put a 6 in there, I got 42. And then when I put a 0 in there, well, this is going to be 0, this is going to be 0, and this is going to be 0. So when I subtract them, I'm going to get 42 pi. Okay? Now, that is if I took this line and rotated it all the way around. Okay? And this whole thing was a solid thing. The problem is everything underneath this C, underneath this curve, is actually not going to be part of my volume. And so I've got to take it away. So now what I'm going to do is I'm going to do this. Let's see, where can I go? All right, so now I'm switching gears. And what I'm going to do is I'm going to do this. I'm going to integrate this. But keep in mind, I have to square it. So first I'm going to get the exponent on the top. Y is equal to 8 times x plus 2 to the -1, okay? Now keep in mind, but when I'm doing volume, I have to square it. I need what y squared. So what this is going to be is this squared. So 8 squared is 64, not a big deal. And this squared is going to be x plus 2, and I multiply these two powers, and I get -2. All right, this is the guy that I'm actually going to integrate, okay? And when I do that, I'm going to write this x plus 2. I'm going to raise the power to -1. I'm going to take the 64 and divide by -1, giving me -64. And then I'm going to put in my 6 and my 0. Pause it and tell me what you get. And start back up when you're ready. Okay, so hopefully you did that, and we've found if you put a 6 in there, that hopefully you got a -8. And then when you put a 0 in there, you got a -32. And so -8 plus 32 is going to be 24 pi. Now, so now what I've got to do is take both of these guys and subtract them. Whenever you're finding the volume of some kind of shaded area that's away, it's not connected to this, I'm finding the volume of this when I spin it around. This is open space. And so what happens is that if I find the volume of this line, it is like me taking this line and rotating it around and getting, well, kind of a shape like this. Okay, but it's the entire thing is solid. And see, what I need to be able to do is it's just this part. This inner part is going to be like an open circle. I don't know how to explain that. Anyway, so what we're going to do is find the volume of the top one rotated around, and then find the volume of the bottom one rotated around, and then you subtract them, and that'll give you the volume of the shaded area. All right? Anyway, that wasn't too bad. That's worth 6 points. Here you can see this. We get the 42 pi. Method point for finding the integration, doing the integration, and then getting this set up correctly. And actually, so what happens is the method is using the volume formula correctly, and then you're getting 2 points for doing the integration correctly and actually getting this answer. And then here, what we're going to do is find the volume under the curve. We get that answer. That's worth another point. And then you get a method point for subtracting them, and then another answer and an answer point for actually getting the right answer. All right, that's going to be it for today. Thanks for watching, and we'll see you next time.